Imagine standing on the surface of a distant celestial body, millions of miles away from Earth. The ground beneath your feet is a desolate landscape of craters and dust. The sun, a blazing inferno in the sky, bathes everything in an eerie, harsh light. But you can't take in the view for long. You have only 5 precious seconds. 5 seconds to experience what it's like to be on Mercury's moon. Here's the thing, Mercury, the smallest planet in our solar system, doesn't have any moons. Neither does Venus. It's a cosmic quirk, a reminder that our solar system is a place of incredible diversity. But what if, for the sake of our thought experiment, Mercury have a moon? What if we sent an intrepid explorer on a mission to this hypothetical moon? What would those 5 seconds be like? The first thing our explorer would notice is the lack of atmosphere. Imagine stepping out onto a surface where the sky is perpetually black, devoid of the familiar blue hue we see on Earth. The absence of an atmosphere means there are no air molecules to scatter sunlight, creating a stark, eerie darkness even when the sun is shining brightly. On Earth, the atmosphere is our protective blanket, regulating temperature and providing the air we breathe. It shields us from harmful solar radiation and helps maintain a stable climate. This delicate balance is what makes life possible on our planet. On Mercury's hypothetical moon, there would be no such blanket. The surface would be exposed to the harshness of space, with extreme temperature fluctuations between day and night. Without an atmosphere, there would be no protection from meteoroids, and the surface would be pockmarked with craters from constant impacts. The sky would be black even in the daytime because there are no air molecules to scatter sunlight. This means that the sun would appear as a blindingly bright point of light against a pitch-black sky, a stark contrast to the soft, diffused light we experience on Earth. Without an atmosphere, there's no air pressure. Air pressure is what allows us to breathe and keeps our bodily fluids in a liquid state. In the vacuum of space, the lack of pressure would have immediate and severe effects on the human body. And what does that mean for our explorer? The absence of air pressure would cause the gases dissolved in their blood to come out of solution, leading to a condition known as ebullism. Well, within those first few seconds, the lack of air pressure would cause the gases dissolved in their blood to literally boil. This is because, in a vacuum, the boiling point of liquids drops significantly, causing bodily fluids to vaporize at body temperature. Imagine bubbles forming in your bloodstream. This would lead to swelling, tissue damage, and severe pain. The lack of oxygen would also cause unconsciousness within seconds, followed by death if not immediately remedied. Not a pleasant way to start a visit. The hostile environment of a world without air serves as a stark reminder of how unique and precious our Earth is. The atmosphere not only sustains life but also protects us from the many dangers of space. As we explore other worlds, we must always remember the delicate balance that makes our home planet so special. Temperatures on this hypothetical moon would be another extreme. Imagine a place where the environment is so harsh that it challenges the very limits of human endurance and technology. Mercury itself experiences wild temperature swings, from a scorching 800 degrees Fahrenheit, 430 degrees Celsius during the day, to a frigid minus 290 degrees Fahrenheit, minus 180 degrees Celsius, at night. These extremes are due to Mercury's lack of a significant atmosphere to retain heat, causing rapid temperature changes as it rotates. Let's assume our explorer lands on the side facing the sun. The moment they step onto the sunlit surface, they would be greeted by an overwhelming wave of heat. The temperature would be so intense that it could instantly start to damage their suit if not properly shielded. Instantly, the unprotected side of their body would begin to cook, while the shaded side would start to freeze. This stark contrast would create a perilous situation, as the human body is not designed to handle such rapid and extreme changes in temperature. Talk about a hot and cold dilemma. The challenge of surviving in such an environment would require advanced technology and innovative solutions. Specialized suits with adaptive temperature control systems would be essential to protect the explorer from these harsh conditions. This extreme temperature difference would put immense stress on the human body, far beyond anything we've ever experienced. The physiological effects could be severe, including thermal burns on one side and frostbite on the other. The stress on the cardiovascular system would be immense, as the body struggles to maintain a stable internal temperature. In addition to the physical challenges, the psychological impact of such an environment cannot be underestimated. The constant threat of extreme temperatures would create a high-stress situation, requiring mental resilience and focus. Surviving on this moon would not only test the limits of human endurance but also push the boundaries of our technological capabilities. It would be a true testament to human ingenuity and the spirit of exploration. Section 5. The unseen danger, radiation. Beyond the lack of atmosphere and the searing heat, there's another invisible threat, radiation. Mercury is the closest planet to the Sun, meaning it's bombarded by intense solar radiation. This radiation, if not shielded against, is incredibly harmful to humans. It can damage DNA, increase the risk of cancer, and cause a host of other health problems. 5 seconds might not seem like a long time, but in this environment, it would be enough for a lethal dose of radiation to penetrate the body. Section 6. The human body out of its element. It's important to remember that the human body is adapted to the very specific conditions found on Earth. We need oxygen to breathe, a certain range of temperatures to survive, and protection from the harmful radiation that bombards our planet. Stepping onto the surface of Mercury's hypothetical moon would be like stepping into a deadly alien world. Our bodies simply aren't equipped to handle the harsh realities of this environment. Section 7. 5 seconds later, a grim reality. So after 5 seconds on Mercury's hypothetical moon, what would be left of our intrepid explorer? The lack of atmosphere, the searing heat, and the intense radiation would all take their toll. It's safe to say that those 5 seconds would be the shortest and very last seconds of their life. Section 8. Exploring the solar system challenges and rewards. The journey to explore the vast expanse of our solar system is filled with both daunting challenges and incredible rewards. This grim thought experiment highlights the immense challenges of space exploration. Venturing beyond Earth means confronting environments that are radically different from our own. The vacuum of space, extreme temperatures, and high levels of radiation are just a few of the harsh conditions that astronauts and spacecraft must endure. These environments test the limits of human endurance and technological innovation. It means pushing the boundaries of our technology and our understanding of what it means to survive. Engineers and scientists work tirelessly to develop advanced technologies that can withstand these extreme conditions. From designing spacecraft that can travel vast distances to creating life support systems that can sustain human life on distant planets, the challenges are immense but not insurmountable. But these challenges also come with immense rewards. The pursuit of space exploration drives innovation and technological advancements that have far-reaching benefits beyond space travel. The knowledge gained from these endeavors can lead to breakthroughs in various fields, including medicine, materials science, and environmental science. By exploring the solar system, we gain a deeper understanding of our place in the universe. Each mission provides valuable data that helps us piece together the history of our solar system and the processes that have shaped it. This knowledge not only satisfies our curiosity, but also helps us make informed decisions about the future of our planet. We learn about the formation of planets, the potential for life beyond Earth, and the incredible forces that shape our cosmos. The search for extraterrestrial life, in particular, captivates the imagination and drives us to explore further. Discovering even the simplest forms of life on another planet would have profound implications for our understanding of biology and the uniqueness of life on Earth. The challenges are great, but the rewards are even greater, making the pursuit of space exploration a noble and worthwhile endeavor. Section 9. Seeking life beyond Earth. The importance of habitability. The hypothetical scenario of Mercury's moon also underscores the importance of habitability when searching for life beyond Earth. When we look for signs of life on other planets and moons, we look for the presence of liquid water, a stable atmosphere, and a source of energy. These are the essential ingredients that make life as we know it possible. Section 10. Mercury's mysteries, what we know and what we don't. While Mercury may not have a moon, this small rocky planet still holds many mysteries. We've learned a great deal about Mercury from spacecraft missions like Mariner 10 and Messenger. We know that it has a surprisingly large iron core and a very thin atmosphere called an exosphere. But there's still much we don't know. Future missions like the European Space Agency's Bepi-Colombo mission aim to unlock more of Mercury's secrets and shed light on the processes that shaped our solar system. Section 11. The final frontier, our continued fascination with space. The vast expanse of space continues to captivate our imaginations, sparking our curiosity and driving us to explore the unknown. While the journey may be fraught with challenges, the rewards of discovery are immeasurable. As we continue to push the boundaries of space exploration, we do so with a sense of wonder and a thirst for knowledge that will undoubtedly lead to new discoveries and a deeper understanding of our place in the cosmos.